For the rest of the summer, the lessons we're going to talk about have to do with geometry. It's very, very important in both pre-algebra and algebra and problem solving to have a good foundation in geometry. When you get to the actual course in geometry, you'll learn it into much greater depth, but we're looking for just a good foundation. And one of the most foundational aspects of geometry is what's called the Pythagorean Theorem. The Pythagorean Theorem is a great application of algebra, and it's a great, very, very powerful theorem that is used very often in problem solving. The Pythagorean Theorem, as you can see defined up here, says that in a right triangle, the three sides have a specific relationship defined by the formula a squared plus b squared equals c squared. And this is everything in the Pythagorean Theorem. A squared plus b squared equals c squared. You need to know what a, b, and c are. A and b are the legs of the triangle, and c is the hypotenuse. As you can see below, I've defined those. The hypotenuse is always the side opposite the right angle. It's also always the longest side. Those are kind of the two ways to identify it. The legs of a right triangle are always the two that are next to or adjacent. Adjacent's a geometric term that's used often. Adjacent just means next to, and it's next to the right angle. And so these two sides right here of this triangle are the legs because they're next to the right triangle. So that means that if you take the length of this leg and square it, and length of this leg and square it, then it must be equal to the length of the hypotenuse squared. So we work some examples of this. The first example says find the missing side. So we're going to use a squared plus b squared equals c squared. Well, we have to identify what a, b, and c are. A and b are the legs. The legs are the sides next to the right triangle. So in this case, they are 3 and 4. So we're going to do 3 squared plus 4 squared equals c squared. Now, c is just going to be this. And so this is going to give us c squared, which is something that we need to pay attention to because we don't want c squared. We want what is c, not what is c squared. So we're going to have to do something in a second. So 3 squared is 9, 4 squared is 16, and that equals c squared. So 25 equals c squared. We don't want to know what c squared is. We want to know what c is. So c is just the square root of c squared. So the way that we solve this equation, that's an equation there. A squared equal to a number, is you take the square root of both sides. The square root of c squared is just always going to be c, which is what we want. Square root of 25 is 5. Right? Remember, square root is just the opposite of squaring. The square root says what number squared equals 25. Well, 5 squared equals 25. So the length of this side is 5. And occasionally, when we're doing these problems, we're going to have integer answers. And whenever we have integer answers, they form what we call a Pythagorean triple. 3, 4, 5 represents a Pythagorean triple. And every time you see 3, 4, and 5 as the sides of a triangle, you know it is a right triangle. For example 2, we're also asked to find the missing side. This side is different from the last problem because we know what one of the legs are, but we don't know what this leg is. So we're just going to call this leg A. We could call it B, we could call it X, whatever you wanted to call it. And so that means A squared is just A. The other leg squared is 24 squared. And then that's going to equal C squared, or the hypotenuse squared. Remember, hypotenuse is opposite the right angle on the other side of the triangle. So we're going to do 26 squared. So it gives us a squared plus 576, 24 squared equals 676, 26 squared. Now we have an equation that needs to be solved. And we want to solve it the same way we did up here, which means we want to take the square root of both sides. However, we don't want to take the square root of both sides until we've isolated the a squared. So we need to subtract 576 from both sides. That will allow us to have a squared equals 676 minus 576 is 100. Now I could take the square root of both sides, and a is going to equal 10. 10 is the third side of this triangle, making it a right triangle. This is also what we call a Pythagorean triple because the three sides represent our integers. Whenever the three sides of a right triangle integers, it's called a Pythagorean triple. Okay, we're going to do a couple more examples here. This one says find the value of c. Now, I put this problem in here specifically because I wanted you to think about the Pythagorean triple more about leg squared plus leg squared equals hypotenuse squared, rather than a squared plus b squared equals c squared, because that can get you in trouble sometimes. Because in this case, I've identified this side as c, which is usually represents the hypotenuse, but that side is not a hypotenuse. So in this case, the two legs are c and 12. And so we're going to have 12 squared plus c squared. Those are the two legs, so those go together. They equal the hypotenuse, which is 16. So though c is usually used for a hypotenuse, it's not always used for hypotenuse, like in this problem. So now we need to solve it like the last problem. 144 plus c squared equals 256. Subtract 144, because we always want to get the c squared by itself. That gives us c squared equals 112. We want to take the square root like we have been doing, but this time, square root of 112 isn't an even integer. So for the time being, we're going to just be finding a decimal approximation for this. Okay, we're going to use our calculator. We're going to type in the square root of 112. In this case, we're going to get, and we're going to round to the nearest tenth, we're going to get 10.6. So the side in this case is 10.6. Later on, you're going to learn to simplify this into a better form, but for now, all we're going to do is just give us a decimal approximation, which would be 10.6. Okay, last problem. Two sides of a right triangle are 7 and 24. What are the possible values of the third side? Well, this is a tough problem because you actually have to do two problems in one. One problem says that the two sides are both legs, 7 and 24, and you're trying to find the hypotenuse. The other problem is one of these two is the hypotenuse. Now, hopefully you're realizing that 24 would have to be the hypotenuse. And now you're trying to find out what the leg would be. So there's actually two different possibilities here for that third side, because I didn't tell you if 7 and 24 are legs or if they're a leg and a hypotenuse. We know 7 has to be a leg because it's the longest side is always the hypotenuse, and 24 is longer than 7. But we don't know what 24 is. So we got to do two different problems. So the first one, 7 squared plus 24 squared equals c squared. And so that's going to give you 49 plus 576 equals c squared. 49 plus 576 is 625. Hopefully by now, 625 is becoming a number that you're familiar with, because 625 is 25 squared. So when I take the square root of 625, I'm going to get 25. So one possibility for the side of the triangle is 25. So for this possibility, we have this is a Pythagorean triple, right? Because they're all integers. The other possibility would be, instead of 24 being a leg, 24 is the hypotenuse. So you're going to have 49 plus b squared equals 576. So this time we're subtracting 49 instead of adding it. So you get b squared equals, well, you do 576 minus 49, which would give you 527. Take the square root of both sides, and so using your calculator, because we don't recognize 527, you take the square root of it, and you actually end up with approximately 22.96. If we're rounding to the nearest tenth, it would be just 23.0, right? But it'd be approximately, so even though it rounds to an integer, this is not a, let me write that a little better for you. This is approximately 23.0. Even though it rounds to an integer, it's not a Pythagorean triple because it actually has to be an integer. So in this case, 23.0 would be the right answer, but that's because you rounded it to that point. So that's how you do problems with the Pythagorean theorem. It's an important theorem to know. It has a lot of applications in problem solving, has a lot of applications in algebra, and is used very, very widely in geometry. So it's one of those things that you have to be very,